Welcome everyone to our first lecture in the solutions for these project exercise questions. We'll begin with the exploratory data analysis section. Let's get started. Okay, here I am at the exercise notebook. I'm going to start off by running the first couple of starter code cells. So that's importing the data that allows us to run our feature information function, as well as loading in the actual data set that we'll be working with. So it looks like that's all loaded up. Next, let's begin exploratory data analysis. So as I mentioned before, it's always a good idea, especially with classification problems, to do a count plot to explore the actual balancing of your labels. So we'll say SNS count plot, and we'll say loan status, and say data is equal to DF. So that's how you can create a count plot here. And I would say this is an unbalanced or imbalanced problem. Notice that we have a lot more entries of people that fully pay off their loans than we have people that did not pay back. And this is really common for things like classification problems that have to do with fraud or spam. There's a lot less instances of fraud or spam than there are of legitimate actions, such as a legitimate email or a legitimate credit card purchase or a legitimate loan where it was fully paid off. So that's something to keep in mind. And what that means is we can expect to probably do very well in terms of accuracy, but our precision and recall are going to be the true metrics that we'll have to evaluate our model based off of. And we shouldn't expect to perform that well on those particular metrics due to the fact that we have a very imbalanced data set here. So next, we want to create a histogram of the loan amount column. Lots of different ways we can do this. Probably the easiest way is to simply call a distribution plot on that column. So we can call df loan amount here. And since I just want the actual histogram, I'll say KDE is equal to false. And if you just run that, that basically gives you the basics of the histogram. Then you can begin playing around with things like the bins. So if you wanted more bins, you can increase the number of bins there. And you can also play around with things like size. So you can always say PLT figure fig size is equal to some tuple. So usually for histograms, you want them long but a little shorter. So you get something that looks like this. Okay, so lots of different ways you can do that, but this essentially something to notice here is you see these spikes happening at these even money amounts, which kind of makes sense. So clearly these bin spikes are happening at something like an even $10,000 loan instead of a spike at some random value like 8,333. So that's what these little spikes are essentially indicating, that there are certain amounts that are basically standard loans. Okay, so let's go ahead and explore the correlation between the continuous feature variables. So we can easily do this by simply just saying df and then calculating the correlation as such. So it's just a simple method call. We've seen this already a bunch of times throughout our lectures. We've also seen a little bit of how we can visualize it. So the way we can visualize it is by calling SNS heat map on this particular correlation, and we can also say annotation is equal to true. So we have those actual links for you in case you're interested in those. And I will go ahead and change the color mapping to be CMAP this, just because for me that's always a little clearer. So if you run this just by itself, you'll get this kind of really shrunk down heat map. So something you can do first off is expand on the size, say PLT figure, and this should always go before your Seaborn command. Say fig size, and let's make this quite a bit larger, something like 12 by 7. You run that, and it will be a lot more improved, but something to note here is that depending on your version of Matplotlib, you'll notice that the bottom and the top are actually kind of cut off here, and you can check out the links we provided for you for help with resizing. So specifically this second one, we'll actually talk about that little error, and that's due to Matplotlib not playing well with Seaborn. So the way you can edit that is by messing around with the Y limits. So there's lots of different solutions. So one way, and we show this in the solutions notebook ourselves, is after you do the Seaborn call, simply say plt ylim, and they say go from 10 to 0 or something like that, and that will stretch out the actual heat map. Okay, so that's our heat map. We can see the various relationships between the features, And obviously you would get a perfect correlation along the diagonal. So moving along here, what we're going to see is you should have noticed almost perfect correlation with this installment feature. So if we come back up here, notice that the loan amount has a 0.95 correlation with this installment. So that's quite interesting. So let's explore this feature further. We want to make sure that we're not accidentally leaking data from our features into our label. So we always want to make sure that there's not a single feature that is a perfect predictor of the label, because that basically indicates that it's not really a feature, it's probably just some duplicate information that's very similar to the label. So let's go ahead and print that out. We'll say feature information on that installment. So we go ahead and run this, and the installment is the monthly payment owed by the borrower if the loan originates. So keyword being if. And then we'll also say feature info on the loan amount. And this is the listed amount of the loan applied for by the borrower. So it pretty much makes sense that the installment and the actual loan amount would be extremely correlated, because they're essentially correlated by some sort of internal formula that this company uses, which kind of makes sense. If you loan someone out $1 million, you would expect that following some formula, your payments, your monthly payment installments are going to be quite high. And you'll probably use that same formula even if you loan someone $1,000, and then those payments will be likely correlated to be much less. So they're clearly using some sort of formula that is just a direct function of the loan amount to figure out what the installment should be. And we can always just do a scatter plot to confirm this. We can say SNS scatter plot, and we can view this high correlation. So we see X installment, Y is equal to loan amount, and then data is equal to DF. So we run that, and we'll be able to see these actual scatter plots. And you can do things like turn off the marker edge, make alpha a little lighter, etc. Okay, so next we want to create a box plot showing the relationship between the loan status and the loan amount. So this is going to answer the question, is there a relationship between maybe really expensive loans and not being able to pay them off, or very low amount loans and then fully paying those off? So what we do is we simply say, get a box plot on our loan status as the x-axis, and then the y-axis will be our loan amount. And our data still remains that data frame. So this allows us to explore the relationship, and in general, it looks like they're pretty similar. Charged off loans, on average, you can see this box plot is slightly higher, meaning that if our loan amount is higher, we have a slight increase in the likelihood of it being charged off, which again intuitively makes sense that it's harder to pay back larger loans than it is smaller loans. So they're extremely similar here, so this isn't a key indicator of whether or not someone's going to pay off their loan, the actual amount they take off, but there is a slight relationship there that we can see from this box plot. And we can do this by just calculating summary statistics for the loan amount grouped by the loan status. So I can say the following. I'll say DF group by loan status, and then if I just group by loan status and then ask for describe, it will show me this for all the columns. So notice here there's kind of a really large data frame, when really all I'm interested in this particular case, since this is what the question is asking for, is the loan amount. And this essentially shows us the quantitative numbers behind this box plot. So if you ever get a case like this that the box plot is a little hard to read, you can always compare the averages here. So you can see the charged off average price is a little higher than the fully paid loan. Okay, so again, all this is indicating is the averages of the loans for people that aren't able to pay them back are slightly higher than the averages for people that do pay off their loans. That's what's indicated with the box plot, and if it's a little hard to read, you can always just manually check this out. So that's what these tasks are trying to get you to realize. Next, let's go ahead and explore the grade and subgrade columns that Lending Club attributes to the loans. And then the first question is, what are the unique possible grades and subgrades? This should be pretty straightforward. You can just simply grab the grade column and then ask for unique off of this, and you should be able to do the same thing for the subgrade column. Simply say unique, and we can see right away that the subgrades basically contain the information of the actual grade itself, because it contains the letter grade and then some sort of sub character. And if we ever wanted information on what it represents, we can always say feat info and then pass in something like subgrade, and it will report back the lending club assigned loan subgrade. Okay, so we scroll down here and we want to create a count plot per grade and set the hue to the loan status label. And this way we can see if there's differentiation between fully paying off your loan or having it be charged off based off your grade. So we'll say SNS count plot. We'll say X is equal to grade. Data is our data frame. And here the hue, we'll go ahead and have it be our loan status. We run that, and here we can see the kind of a clear relationship, but what's a little hard to tell here is the ordering of the actual grades. So notice that we're starting with B and then going A, C, E, D, F, G. So it would be nice, and what we're going to do in the next problem, or next task, is actually show you or have you figure out how to reorder these x-axis ticks. But essentially what this is showing is the percentage of charged off loans looks like it's increasing as the letter grade gets higher. So it looks like the best customers are given a grade of A, the second best given a grade of B, C, D, etc. And we can do this by actually comparing the ratios here. So let's take a further look at this. Let's actually do it by subgrade. So we may need to actually resize to try to get this plot, but what I'm going to first do is get a count plot of these subgrades to see this distribution throughout the entire data set. How many A1s do we have? How many A2s do we have, etc. And we can see from the answer, it looks like the majorities are A, Bs, and Cs, which kind of makes sense because these are clearly the riskier loans because they're more likely to be charged off based off what we've seen here on the overall grades. Notice that the fully paid versus charged off rates almost look the same for someone in the G grade category. So how do we actually show this count plot per subgrade? Well, we simply say SNS dot count plot, and then we'll say X is equal to subgrade. Recall there's an underscore there. And then our data is equal to DF. Now, if you just run this plot, you'll get something that looks like this. So the first thing we should fix is the size of this plot. So we'll do that by saying PLT figure fig size is equal to, and let's go ahead and make this 12 by 4. Okay, so that takes care of the sizing. However, what I want to be able to do is reorder that x-axis. So if you do a little bit of research on the count plot in Seaborn, essentially just go to the Seaborn API or tutorial page and then look up count plot. So it'll be here in the categorical plots. You'll notice that there's actually an order parameter, which is just the list of strings. So that's the order you want it in. So let's go ahead and figure that out. So what we're going to do here is we'll say our subgrade order desired is equal to, we'll come back up here and use what we did before, where we printed out the actual unique subgrades. So we'll copy that, and then we'll just sort them using basic Python. So base Python has this sorted function, and essentially what we're doing here is we resize the plot, and now we have this list of the subgrade order, which is this sorted call of the unique subgrades. And then I'll pass that in as my order here. So we'll go ahead and say subgrade order. Run that, and now you should see everything ordered. The last thing to note here is something I disliked is the color seemed to be too similar between A1 or the A groups and the G groups. So then I just chose a palette that basically doesn't allow for that. And in my case, after exploring the documentation on matplotlib, I liked cool warm. So we can see here the essentially better grades are bluer and the worst grades are redder. Okay, so here we can see that it essentially looks like F and G subgrades don't get paid back that often. So we want to isolate those and recreate the count plot just for those subgrades. You'll also notice that up here it also asked you to maybe feel free to play around with the hue. So on this second plot, we just had the loan status hue, so we can kind of compare that as well. So you can always do that by just coming up here and saying hue is equal to loan status. And then you get that plot. So lots of information here that we can deem just from the visualization. And clearly, these worst grade categories, it looks like the charged off rate is almost the same as the fully paid rate. So it might be worth investigating if it's even worth giving people loans if we're going to grade them a G or an F. And what we're going to do here is we're essentially going to kind of zoom in on that little section of the plot. And the way we're going to do that is simply the exact same code, but we're going to do a quick filter first using pandas. So I'm going to essentially copy and paste this code. We'll come back down here, paste it here, and what I'll do here is say I just want F and G. So I'll say F and G is equal to my data frame, where my data frame grade is equal to G, pipe operator, or where the grade is equal to F. And then I'll wrap these guys in parentheses to make sure I don't get an error. And then in the rest of these lines of code, wherever I have DF, I'll just replace that with F and G. So we'll grab our subgrade order there, and we'll set our data there. Okay, so all we're doing is essentially subsetting the data frame and then doing the exact same plots as above. So if we run that, now we can see the fully paid status versus charged off status for these essentially worse subgrades. And you'll notice that if you're graded G5, the likelihood is almost the same as fully paying off your loan versus being charged off on the loan. Okay, we have one more plot to create. And in order to create it, we have to complete first this task, which is create a new column called loan repaid, which will contain a 1 if the loan status was fully paid and a 0 if it was charged off. So right now, our label column is such that it's strings, and I want to change that to essentially map to a 1 and 0. So lots of different ways we can do this, but one way is to simply say my loan status, go ahead and map the fully paid, and I can just copy these. And you can grab this just with a unique call, but go ahead and map fully paid to be 1, and then map charged off to be 0. And then we wanted you to set this as a new column, and we'll set this as a new column called loan underscore repaid. And this will actually be the label column that we use when working with TensorFlow. So go ahead and run that, and then you should be able to then view both of them. So let's go ahead and show that. So we have loan repaid, comma, loan status. Just see those two, and we can see that it worked. So loan repaid, it's a 1 if it got fully paid, it's a 0 if it was charged off. So now that allows us to complete our last visualization, which we've actually already done in previous lectures. So it's technically a challenge task, but there's a helpful link in case you need help. And what we wanted to do is essentially do this plot that shows which numeric features have the highest correlation with the actual label. And we did this in our classification tasks, or in our classification lectures before, but let's go ahead and show you again how to do it. First step, actually calculate those correlations. Next step is to only grab that loan repaid column. After that, what you can do is say plot kind equals bar, and that gives you the very basics of what this plot is doing. However, one thing to notice is loan repaid is going to be included and it's not sorted. So what we can do here is before we call plot, we'll go ahead and say sort those values, sort underscore values. You plot that out, and now you get the sorted version here. However, it makes sense that loan repaid is perfectly correlated with loan repaid, so we will go ahead and drop loan repaid. And I don't need to specify axes because this is actually now a series from the correlation data frame. Run that, and now you will get back the exact same plot here. So we can see that interest rate has essentially the highest negative correlation with whether or not someone's going to repay their loan, which kind of makes sense. Maybe if you have an extremely high interest rate, you're going to find it harder to pay off that loan. Okay, so that concludes this first section of the exercise where we just explore the data and perform visualizations. I would highly encourage you to not just do the visualizations here in the notebook, but play around with the data yourself and see if you can answer any questions that you have based off your domain knowledge and based off what features are interesting to you. Thanks, and I'll see you at the next lecture where we continue with section 2 on data preprocessing. I'll see you there.